Good afternoon, good morning all. Welcome to the next session on Green Cementech Day 2. We are privileged to have Mr. K.N. Rao as session chair today. Mr. K.N. Rao, currently working as head sustainability at My Home Group. He is having a vast experience, a well-known figure in the cement industry. So he's having more than 35 years of experience, and he's a postgraduate from IIT Chennai. And he's also worked on several multilateral and international groups in terms of WBCSG, several international organizations and Indian organizations like FICCI, CII, VII, Ministry of Power. So his vast experience in the field of sustainability, energy, and environment management. We are privileged to have you, sir. Request you to please take care and conduct the session, sir.
Thank you, Mr. Kannan. So welcome to the second session of the Green Cementech second day conference. I think we are in a very, very interesting subject. I think from the yesterday morning, I think all of you know that our whole agenda is for how to become a net zero journey for the cement industry and what are the levers available. And today, one of the important topics which we'll be discussing in this parallel session is on alternative fuels and how we can increase the usage of alternative fuels and how we can reduce the CO2 emissions coming from the alternative fuels. And so today we have two companies who are going to take about alternative fuels, how to increase it to the 25% of the kiln fuel requirement. That's going to be the one topic. Other important aspect is on the environment side. We have a lot of cement kilns now with the new regulations of Government of India, how to reduce the particulate emissions to less than 30 milligrams per nm cube, and also how to enhance the bag life of the cement kilns in the process that the availability of the kiln is not affected, and at the same time we maintain the low emissions and low pressure drop, and which ultimately helps us to reduce the energy consumption of the baggers, and in the process that we may able to maintain energy efficiency and emission levels reduction to the level to the global standards. So we have one speaker from on P84, which is the latest well-experienced filter bag on the cement industry. And we have two suppliers who are going to speak on how to enhance the usage of the alternative fuels in the cement kilns. And then we have the last presentation is in terms of by Mr. Kannan. He's going to speak about how to enhance how to benchmark and enhance the alternative fuels in the cement kilns. So these are the four presentations. We'll start with the first presentation by Mr. Jose Jacob. He's the Managing Director of Anthony Waste Handling Cell Limited, and he's basically a bachelor from mechanical engineering, having 18 years experience in the waste management, and he's also have actually taken a leadership course in Harvard Business School from Boston. So I first invite Mr. Jose Jacob to make his presentation.
Thank you, sir. And Satish, can you? Yeah. So we are sharing the presentation.
Yeah.
Good morning to all the participants. Can you see? Yeah.
Yeah, you are visible.
Yeah. Okay.
It's Mr. Satish also.
Yeah. Yeah, Satish is there. So we just. Yes, sir. Yeah. Yeah. By second time. Mm-hmm. So I'll just start by giving brief. I think it's some problem with the screen. So Anthony Waste Handling Cell was formed in year 2001. And the idea in those days was like, municipal solid waste rules had come in year 2000, where waste handling had to be mechanized. In the past, it was more of a traditional handling of municipal solid waste. So we started off as a collection and transportation of municipal solid waste with refuse compactors, closed bodies. So refuse compactor, once was introduced, there's less manual handling and it is more hygienic. And that is the reason, as per the Honorable Supreme Court's Rule 2000, we all the municipal corporation had to adhere to those rules. And we as a service provider got an opportunity to get into the business. And so this is how we have been growing. Anthony Waste Handling Cell has a multiple subsidiary based on the requirement of the municipal corporation. And from 2001, we kept on growing as a collection and transportation business. And somewhere in 2008, we won one of the largest waste processing contract of Mumbai, where we are approximately processing 60 to 70% of Mumbai's waste. And this contract was signed between us and as a JV with a Brazilian company with Municipal Corporation Greater Mumbai. Contract is for a 25 years period. And as of date, we are processing around 5,000 tons of waste, which is one of the largest in India and one of the largest single location in Asia. So this is our track record. We have a strong execution team. We have a well-trained team in waste management, and that's how we are moving away. And so you can see how we have started off from door-to-door collection, then we got into transportation, and then segregation by waste processing and recycling. And we are also selling the recyclables to recycling industries. And on compost, we are supplying around 2,000 tons of compost per month. And RDF, we have presently supplying around 300 tons per day to various cement factories. So these are the projects we are doing pan-India level. So large part is collection transportation. Waste processing, we are doing one in Mumbai. And second one, we are setting up a waste to energy project in Pimpri Chinchwad. So this is all CNT business, and we are also entered into biomining, where we have one contract in Greater Noida. We are mining the legacy waste, and out of which the RDF, whatever is produced, presently we are selling to a cement factory close by. So, so here you can see we are processing around 5,300 tons per day. We supply even power. Presently, the power, whatever we are generating through biogas or landfill gas, is used for captive consumption. In future, we may think of selling it to the grid. So you can see our ranking. We have been doing wherever we are providing services. You can see that from NDMC we have ranked 1, Navi Mumbai we have been 4. So various places the ranking has improved substantially after we won the contracts there. So as I said about this is how we do. We get the fresh waste. We have a full-fledged material recovery facility which we have imported from America, and we have a shred, primary and secondary shredder of SSI, and presently we shred and produce RDF for ready for use, which is about 80 mm. And this is how a landfill, bioreactor landfill. We have a MRF and composting unit also. And you can see here we are also making pellets, and there's a huge demand of pellets. We are selling a big amount of around 50 tons per day or 100? Yeah, 50 tons per day. This, as you all know, the composition of RDF. You can skip this. So you can see this way how the vehicles are coming in. This is a MSW intake, and how we process biological process to produce compost. This is a compost plant where it is totally SCADA system. Manual intervention is almost negligible here. And here we make compost pellets also, as well as RDF. Yeah, we are selling it to RCF, and so I think this is what we are planning is we are importing around 8 numbers of shredders, and by October post monsoon, we will be in a position to supply around 1,200 tons of RDF to various cement factories to achieve their goal of reducing coal. So this is our MRF facility. And our RDF, one good thing is our RDF calorific value is good in the range of the 3,000 to 4,000. And one of the main reason is Mumbai waste has high calorific value because many wards of Mumbai is economically well developed. So there is more dry waste coming in. This is a shredded RDF which we are selling. We used to bag in the past. Nowadays we stop bagging because everybody prefer to be bailed in the send by a bigger truck because bailing is difficult for cement plant. They said they have to again reopen it. That's it, sir. Thank you very much, and it'll be a pleasure to support the cement companies by giving high quality RDF as per their requirement. And Satish Salunke is the person who is coordinating on our sale, and we will try a level best that we help the cement plants to achieve their goal of 25% TSR. Thank you, sir.
Thank you very much. I think it's a very good example.
Somebody's in mute, I think.
Yeah. So thank you very much for your excellent presentation. Now we will move
Sir, you are in mute.
Sir, please check your voice is not.
No, sir.
Not audible.
Correct. Maybe Satish ji, your internet is low bandwidth. His voice is clear.
अपना सुना नहीं क्या?
Rao sir, your voice is clear, so you can go ahead.
Yeah. We will move to the next presentation, and we will have the questions on the first presentation, and once all the presentations are completed, now we'll move to the second one. And Mr. Ashish Maheshwari is from Evonik India Limited. He's having a more than 20 years of experience. Any problem from my side? Or?
No, sir. Mr. Satish is just need to mute it. He has just done that.
Yeah. So Mr. Ashish Maheshwari is having a 20 years experience. He's a chemical engineer, and he's in terms of business development and marketing, and he's actually representing the Evonik India Limited. So now I request Mr. Ashish to make his presentation on his advanced filtration techniques to reduce the emissions of cement kiln.
Session Chairman Ken Rao Saab. Thank you CII Green Cementech giving us the opportunity to share more details about the P84 filter media. So I will just share the screen. Hello, can you see the screen?
Yeah, we are able to see the screen. Yeah, you can go ahead.
Okay. Yeah, thank you. So P84 filter media for efficient, reliable solution for highest filtration efficiency in cement kiln application. Evonik is a creative industrial group from Germany and one of the world's leading specialty chemical company. P84 has a history of more than 36 years in hot gas filtration. The product has been established in 1984 by Lenzing in Austria. Because of the multi-lobal cross section, it has shown the highest filtration efficiency, and we have upgraded this product by P84 HT, which gives the optimum thermal and mechanical properties. At the same time, the strength of hot gas filtration efficiency for P84. This is the location of Evonik Fiber Austria manufacturing facility in Lenzing-Schorfling for P84. How exactly the P84 value chain is there? We manufacture P84 staple fiber and multifilament yarn. Then our customers, they make use of this fiber multifilament yarn to make it support screen, needle felt or filter bags. And that has been delivered to the various customers in cement application. Target is cement industry. Apart from cement, it can go in the metallurgical industry, also in thermal power plants. In addition to this, Evonik supports on the development of the filter bags analysis, why the filter bags are failing. We do the analysis by chemical aging, mechanical aging. We have the facility to evaluate the bag performance and guide to our end user the true report. This will help the end customer what are the failure cause and they will take the proper measures accordingly. In cement application, there are various process filters, pulse jet bag filters have been applied. And P84 being filtration, super filtration efficiency, they can be used in a blended form to the various application. For example, cement finish mill that can be used in a cap with polyester, coal mill along with homopolymer or Nomex that can be applied. And in kiln, it's a P84 based on the PTFE screen. Now, the kiln is one of the heart in the cement application. What challenges we found? Once there is a high dust loading takes place, high air to cloth ratio, there may be high temperature operation, and that results into the blinding of the bags. Or there are mechanical failures, abrasion and delamination of the PTFE membranes. Ultimately, this will result into the excessive energy cost. At the same time, emission goes up and there is a production loss because of the kiln trip and downtime. To avoid this, basically there are two types of filter media as everyone aware. One filter media where the one glass has been put as a screen and on that the thin PTFE layer has been doing applied which does the filtration jobs. This is how the one structure looks. The major challenges are surface damage and the mechanical breakdown, dust passing inside the PTFE membrane. Whereas non-woven filter media has shown a stable operation because there is a scheme, there is a dust side but and clean gas side but. And once this has been done, the will not pass into the P84 filter media. It will form its own layer and that dust cake will also support in filtration efficiency. So this is the cross section of the P84 filter media. After 8 years of operation, you can see there are different, the dust has been uh, inside the surface layer. It will not pass into the cross section. The cross section is free of the dust that ultimately results into the lower emission and longer bag life. The beauty of P84 is basically the surface area. How the filtration efficiency has been decided. The filtration efficiency decided once you have the higher surface area. Round fibers, they have lower surface area as compared to the multilobal cross section. The picture on the left hand side correlate to the same. If you have the round pasta, then the sausage gathered on the pasta will be much lower as compared to the multilobal or this multilobal pastas. Sausage will be more. The same way, dust will be highly removed or the filtration efficiency is highly improved with multilobal cross section. You can see the fiber fineness versus the surface area. At the same time, normally the glass membrane or round fiber, the maximum air to cloth ratio they can operate is around 1.2. So ultimately, that is limitation when you are increasing the production and the gas flow rate, everything. Whereas P84 bags can handle up to the higher AC ratio, up to 1.4 meter per minute. So you have actually virtual filter bag filter, which can play a crucial role in lower the DP and energy demand. There is no equal copy. This is one of the example based in the China where In Sichuan plant for 3,200 ton per day, they have around 4,500 bags approximately. There was a P84 in operation more than 7 years from 2006 to 13. DP was also stable at 6 to 7 millibar, emissions well below 10, and total cost has almost very low. There was energy saving and 100% availability of the bag house. But they have switched to Chinese PI, which is round fiber. So that is one of the crucial point here I would like to mention. Because of the round fiber, the DP has increased from 6 millibar to 8 to 10 millibar, and within 2 years, dust has been penetrated. So that has additionally caused the amount as compared to the P84. And the expected bag life has also drastically reduced as compared to the 7 years. This is the plant in Andhra Pradesh. It is already with earlier with glass membrane, PTFE membrane, designed by Bolrucci for 150 dia, 8 meter long. And the major failures were the premature filling of the woven glass fiber and high emission going up. So we have analyzed the filter bags in our lab in Austria. Analyzed the filter. We found that the damage was at random place, and there are punctures, holes has been done because of the vertical cage wire. So the dust has been penetrating and the mechanical damage has been taking place. So we recommended P84 on PTFE screen, and the plant is running fantastic without any challenges. Similar case with Sonadi Cement Nuvoco plant that is almost in operation from 2016, and still the bags have not been changed. So we are also finding last year we have done the sample analysis and the bags are running very good. Emissions are also well below. Similar case with another plant of Nuvoco group at Sonadi plant line 2. They are also getting the good life. The plant has been replaced with 2017 by P84 on PTFE bags. So the emissions are also below 10. This is what we have got the information. This is another group, Nuvoco Cement Group at Arasmeta location. This is also getting good results for their filter media. This is another plant in Damo, Heidelberg Cement, earlier, former. It started in 2017 and they have changed the bags frequently into say after 6 years, 5 years, partial bag replacement that has taken place. Overall, the bag performance is very good. This is one of the largest reference in UCC cement at Ras Al Khaimah. This plant has started with P84 on P84 screen with around 17,000 number of filter bags with 160 dia and 6,000 meter length. Emissions are well below 5 mg. Recently, the bag have performed more than 8 years. So they have changed this bag in last year. The installation is going. So again with P84. This is with alternative fuel because the theme of the conference is also. So P84 is the beauty that it can handle various types of alternative fuel like municipal solid or rice husk, agricultural waste or pet coke that can be handled and it can play crucial role in these things. Benefits of P84HT filter media in case of clinker cooler or kiln law mill is lower emission, consistent lower emission. So that will help you to gain the more production. Also the baghouse, virtual baghouse is there. So you can increase your plant capacity with the same baghouse. At the same time, it will help in the energy cost because ID fan power of P84 is lower as compared to other filter media. That will affect to the DP also is lower. So we have the tool, we call it as a filtometer, which will help us to quickly evaluate the bag performance you will get. We will also support on maintenance cost, production, planning for the filtration application, filter bag. Or you can also approach us directly at Evonik India. So if you are available, I can share just small video. One moment. Can you see the video?
No. Now it's,
No.
yeah,
Okay.
now it is.
Yeah, so this will guide about the filter media, how the P84 filter bag looks, and after pulsing the dust cake, which is on the surface it has been, and the pressure curve, DP, what exactly. This is how the dust has been imported on the filter. Construction of the felt. Internally, there is a scream. After that, there is a clean side gas and butt side filtration side. Overall benefits, the lowest emission you can identify well below 15, 10, according to your requirement, we can make it. Also the lower DP as compared to other filter media that will ultimately help in energy saving potential. It can handle various types of alternative fuel. So that is one of the best thing. Cage wire requirement is also low. That will also help. And the bag life is also good. Most of our plant, 95% or 90, more than 90% have crossed around more than 7 to 8 years of the filter media bag life we have seen. So these are all the things which will help to cement plant to improve their filtration efficiency, emission control, and production will also be increased. Thank you, everyone.
Thank you, Mr. Ashish. I think it's excellent presentation. Personally, I also experienced this particular bag performance, especially the example what has been mentioned that the bag of skill is increased output. So this is one of the applicable method where you can retrofit, and you need to look into the TCO cost, total cost of ownership, both the capital cost of bags and also the cages and operating cost, fresh air consumption. We see then we'll be able to make a right selection in terms of the fabric. But P84 has been there from for almost more than 3 decades. They're having many installations working efficiently and able to deliver the emissions and also lower pressure drop. So, I think of late in the last 5-6 years, there are many P84 installations came in India. Thank you, Mr. Ashish, and we'll move to the next
Thank you.
presentation, and we'll have the questions at the end. And our third speaker is Mr. Sunil Kumbar, and Mr. Sunil Kumbar is a CEO of Alt SF Process Private Limited. He's having more than 17 years of experience in various equipment-related pre-processing and co-processing solutions related to waste management. He's a mechanical engineer with a MBA degree in marketing, and he's involved in the associated with the commissioning and installation of aircraft systems in India and abroad. I request to start his presentation.
Thank you, sir, for this nice introduction. I hope my screen is visible.
Yeah, your screen is visible. You are audible. Yes, so we can go.
Thank you. Thank you. So AltSF Process is a startup in alternate solid fuels, pre and co-processing. So with the experience in ThyssenKrupp and ATS earlier, I came into this and started this initiative. So we got one support from Pune, one industry who is present in this, and they were working on waste management. They already worked for NEPRA for waste pre-processing and preparing waste segregation from that. So in AltSF, we are associated with Amani Engineers, and we have these group companies, Amani Engineers and Sai Sound Controls. We have various factories in Pune region, where we are manufacturing our equipments for cement industry and as well as municipalities, where waste management or waste processing is done. If we look at our workshop setup for UltraSafe, which is available from Aman Engineers, is we have 3 factories in Pune region, more than 1100 square meters area. We have in-house cranes and also mobile cranes, which provides all sort of material handling necessity in workshop. Our workshop is ISO certified as well. In Pune, we are located in Chikhli area, in Chakan area, and in Pisodi in Katras area. And this versatile arrangement helps us in procuring various equipments necessary for our manufacturing. These are workshop equipments. We have in-house CNC laser cutting, CNC bending machines. Then we do CO2 welding only on our machines. With more than 50 skilled people in workshop, we are able to manufacture equipments necessary for our applications. Workshop is ISO certified, so the processes in workshop are set and are capable to manufacture world-class equipments necessary for our requirement. We have also in-house sandblasting and painting arrangements, which can give us a right finish of the product which is necessary. If we look at our organization structure, myself and Mr. Mahesh, we are partners in the company right now, and we have various teams managing sales, project management, and automations. Basically, designing and marketing is managed by me, and manufacturing and workshop is managed by Mahesh. So we jointly deliver the necessary requirements in alternate fuels. Now, coming to the alternate fuel co-processing, there are various wastes available in the market where some calorific value is present and can be used in cement plant for energy recovery from that, and it results into thermal substitution for them, which is also society benefit and cement plant benefit. There are some examples: biomass waste, threaded tires, RDF, some agricultural waste, other wastes. FMCG rejects, something like noodle packets few years back when it was rejected, came to cement industry for co-processing. So some calorific value is needed in that waste, which can really replace the energy requirement for cement plants. So the requirement currently starts with some grain size handling, moisture content handling, then density range handling. So for this handling, we need some crucial equipments which can flexibly give the acceptability for cement plant to accept any alternate fuel at any point of time. So this is something concept we are working on. For that, we have made 2 divisions. One is pre-processing and one is co-processing. Pre-processing, there are some machines and conveyors required for any pre-processing system. If we talk about belt conveyors, chain belt conveyors, or metallic conveyors, this is something core know-how that our partner company already had, and they prepared many conveyors before as well. So with that, we are able to support on this. For shredders and screening machines, we are dependent with the European counterpart. We have made association with one of the German company, reputed company, present for almost 5 decades in municipal waste management. We are their sales and marketing partner for India. With integration of their shredders and screening machines, we are able to propose a pre-processing system for cement plant as well as for municipalities where this arrangement is needed. When we come to the co-processing, we have developed some equipments, and we are in development for few equipments more. One is called hop feed, which is with kind of arrangement where we can feed material, all sort of alternate fuels. We will see it in next coming slides. Scrap feed and ladder feed are also some equipments we are in pipeline to develop. It's not ready yet. And in conveying of these all alternate fuels, we have various conveyors like dosing belts, chain belt conveyors, metallic apron conveyors, container hoist arrangement. These are some equipment. Some of them are already our working references. Some are in design stage. In calciner end, we propose 2 equipments. One is double wall and one is rotary airlock. Double wall, it's only not wall. It's non-concreted wall, then concreted wall, then pneumatic safety gate, automatically operated, and manual safety gate. So altogether, all this bunch we call cal feed, which is necessary for safe and efficient feeding in calciner. We already have this product, proven product with a new technology. I will show some videos. This is something that we are in the process of patenting as well. Some innovative activities, ideas are put in place and systems are running in successfully in cement plants. Now coming to rotary airlock, here also the technology in India is not yet up to that level. So some of the European companies are helping in that, with which we can work on providing complete RAL feed. Rotary airlock will be only imported. Rest all equipments like pneumatic safety gates, manual safety gates will be integrated by us, and a complete RAL feed equipment will be provided. So coming to each equipment in detail. In co-processing, normally we divide this co-processing into various stages. One is when we receive alternate fuels, we need to have storage, and its automatic handling is something cement industry is looking at currently. When we go for higher TSR, we know that few years back people were talking about only 10 TPH feeding system, but today everybody is talking about 50, 60, 100 tons per hour. So for that, we need a lot of material to be handled automatically. We are coming up with grab crane solutions for that. We have that product proven and ready with us. Then extraction unit, as shown, half feed is the right equipment for that, which will uniformly extract alternate fuels and give you uniform flow on the conveyors. Once it is a uniform flow, it's easy for dosing. So Weibel feeder is the next equipment which will do this dosing. After that remains is the conveying to the preheater tower or kiln inlet, wherever the desired inlet point is. For that conveying, belt conveyor is the most suitable and flexible equipment, but if layout is not permitting, we can go for air floating belt conveyor, or we can go for sidewalls belt conveyor, or we can go for bucket elevator with some limitations, of course. Belt conveyor is most flexible, and air floating belt conveyor is some new concepts coming up in that, where we can have long distances between the supporting towers. And at calciner end, we need some safe equipments to feed like RAL feed and cal feed. This is our first equipment and project by Altasef process, where we have supplied a bottom opening kind of container and hoist arrangement with help of stall, which lifts about 2 meter cube of alternate fuels to the required floor. And that container then moves horizontally to feed into apron conveyor built up with hopper. So this equipment we are also in developing to a dosy feed arrangement. Dosy feed is basically a compact apron conveyor integrated with load cells, which can give you dosy product as per DCS set points. And at the end of it, we will have material to go to calciner. After that, we can install directly double wall or rotary walls to go into calciner. Now, this arrangement, what you are looking into right now is already our successful reference of Altasef process, working for almost now 6 months. After startup, this was the first project executed by us. Now, for more than, but this system has limitations. We are lifting material by container and hoist. So there is a cycle time which is quite long, and it is not able to give you a quick high feed arrangement. If you are looking at more than 50 tons, 5 tons per hour, we need a quite bigger systems on that, where front loaders and cranes are managing the show to feed into the hoppers. We have hop feed equipment, which is a typical developed Altasef equipment, which is basically chain belt conveyor only, but with some special tilt, which can extract a lot of alternate fuels easily. We are putting a rotating drum, a regulating drum for uniform flow out of it. And after that, we have Weibel feeder. This combination will help industry to give a uniform alternate fuels, whatever moisture content it may be and whatever alternate fuel it is. After that, we have conveyors to go to the tower, and then metallic apron conveyor for separation of the belt. After that, we can go for RAL feed or cal feed. Now, to separate, some customers have or they want double wall. If there is no preference, what we propose up to 200 to 50 metric cube per hour, the rotary airlock is a good option. For more than that, we can go for imported rotary airlocks with safety shut-off gate. Now hop feed in detail, we have 30 meter cube hopper capacity. It is synchronized with the dosing belt. So there is a combination of speed which can give you uniform flow. We are using one radar sensors to monitor consistently the height in the hopper, and that gives a signal to the feeding people. We can also integrate that signal into grab crane to feed it automatically. The feeding capacity at outlet is 400 meter cube per hour. Hopper capacity is 30, however, feeding capacity is 400 meter cube per hour. Various sensors are in place to make it automated arrangement. Cement industry can monitor this equipment and its performance from directly their CCRs. So whatever integration is needed through PLC and VFDs is done for that. We have developed a program with the help of Siemens House, supply house in Pune, and it is in directly S7 1500 PLC, which helps to give that necessary actuation for dosing. This is a way belt feeder with some PLC systems and Siemens load cells, which will be integrated with the way belt with hop feed. This is the actual status. We are manufacturing first equipment for this application, and it is under manufacturing. We hope to have it running by end of June in our one of the customer of us. We have designed developed for dosy feed equipment in case some cement plants, obviously when we are going for more than 10% TSR, people will need accurate and responsive feeding system in calciner. Once we want to control the temperature in calciner with respect to alternate fuels, we will need quick reaction time, and this is possible with a compact equipment which can be installed in pre-heater tower directly, and within 1 or 2 seconds you can have that changeover in calciner. So for that we have developed dosifit, which is a metallic apron basically tilted, and on apron itself there is a load cell which will make the measurement and will control based on PLC and VFD feedbacks. There is an integrated hopper of around 7 meter cube capacity which can sustain for that to for the actuated TPH. The conveyor coming into this is also with VFD, so we can control it easily. This is our CalFeed equipment, double wall airlock, where we have pneumatic panel provided to operate the safety shut-off gates. All the panel, safety gate, everywhere we have used all high temperature resistant material. In case there is a high temperature blasting also, reverse backfire also, there is a lot of dust also in the calciner which is at high temperature. So even if it gets exposed to such dust, it will not damage, or the seal will not be damaged. That is ensured. We have provided temperature sensors at the end, which will ensure that once temperature is high, system will be automatically off. In case of jamming, we can still detect that and we can respond to the pre-heater tower. Sorry, to the CCR for further actions for that. We have used a double counterweight so that we on both sides push flaps to get closed always. This is something new that we have done. Let me show the quickly video of it. So we have basically developed this equipment newly with pneumatic receiver tank and all that. This is an actual installation at site. We have special cam arrangement which is opening and closing this flaps, and we are stopping at special intervals when other flap is closed. When the other flap is open. We have various sensors arrangement provided which can integrate both flaps together. There is a cam which is very hard material and roller which is very soft, which gives flexibility to replace rollers as and when required. It's quick replacement possibility. There is a spring arrangement provided which is for landing of the counterweight in case we need a smooth landing. For that it is there. Now coming to the rotary airlock, we are in development stage for local rotary airlock. However, for now we are importing it, and a part of that we are putting motors and sensors, pneumatic safety gate to make it automated arrangement for feeding of calciner. So here there is a plate which is almost like a cutter. In case there is jamming of almost 3-4 mm of any material, it will cut it and it will still run. Very high torque motor is used here. We are providing almost 10,000 Nm torque on rotor knives. This gives no jamming, even in worst case of material. Of course, certain metal parts can't be protected against. If it is comes, it will have some jamming, but there is a provision with some doors around, with which we can help to take it out from that place. Now coming to the pre-processing. In pre-processing, normally storage, shredding, segregation, metal separation, and conveying. These are some of the steps. Here we have some basic layout, full-fledged pre-processing facility where input conveyor is there, which will feed to the primary shredder. Primary shredder is not a shredder, basically, it's a shearing machine. After that, we can go to the intermediate conveyors. After that, there is a secondary shredder. Initially, cement industry started using secondary shredder as a standalone, but somehow that could not achieve the required EPH requirements. And now people are shifting to primary shredders as well. Primary shredder with screening probably will solve the purpose if grain size is good enough, around 60-70 mm, which can burn in the calciner. If not, the future, when you are looking at 50-60% of thermal substitution, the secondary and primary both shredders will be required to give you grain size of less than 50 mm. Screening machines will be required. Some of the plants are already investing in turnkey processing facilities. And I hope in coming years, all municipalities will also start, and cement industry will get a good quality RDF, which is necessary as a fuel for them. We are also developing a liquid handling system. Some of the pumps we have selected, which can help high viscous material to feed into calciner. We are in development stage currently for this. Our references from AltSF, we are already associated with big cement companies for some of their supporting systems. And from our earlier companies, we worked for Kone and Nepra, where we have supplied from Aman Engineers some equipments which are related with waste management. These are our contacts. We hope our presentation was good knowledge for you, and we keep in touch for any further requirements and question and answers. Thank you for this platform.
Thank you, Mr. Sunil, for an excellent presentation. You have covered the entire subject of pre-processing and co-processing and what are the improvements you brought in for the how to substitute the imported equipments, and you are trying to do the total project with the indigenous technology and also with the indigenous materials. And you also brought out the type of challenges. It's an excellent presentation, and all the question answers we will answer after the last presentation is over. Now I request Mr. Kannan to. Kannan is from CII. He's a counselor of CII GBC. He's a chemical engineer with post-graduation from XLRI Jamshedpur, and he's a certified BE certified energy auditor. He's also lead auditor for the ISO 50001. He's having more than 15 years of experience. His expertise involves in the field of cement manufacturing, energy, AFR, and sustainability. I request Mr. Kannan to make his presentation. This is about accelerating the TSR levels in Indian cement industry. I think all of you know that we had an aspiration target of 25% TSR, and many companies have done it, but at the national average, still we are at the range of 4 to 5%. I request Mr. Kannan to initiate the presentation.
Thank you, Sharman. Thank you for the opportunity. Good afternoon, all. We like to share our experience on the AFR mapping study, which is recent activity taken up by CII on increasing the TSR levels. So the outline of the presentation is about the initiative done at CII, GBC, and what are the AFR co-processing, as you know, what are benefits and everything. We just like to touch upon the need for it and the current situation. And about the AFR mapping study, what activity has been carried out with the case study examples and also the way forward. So CII GBC has been working for the past decade on facilitating urban and industrial waste as AFR in various industries, including cement industry. The objective is to reduce the carbon emissions and facilitate win-win situation for all the stakeholders. And in the process, CII has been involved with various stakeholders, both international level as well as at the country level, like the government institutions like MOE, CPCB, SPCB, and international organizations like EU, REI, CINTEF, on improving this particular activity of developing higher substitution levels in the Indian cement industry. So to put up a snapshot of activities, The work has been carried out in three main areas. One is on policy advocacy, second is on technical research and analysis, and third is on capacity building initiatives. So on the policy advocacy front, CI has been participated and developed a team of state pollution control board members and central pollution control board members. A team has been formed and they have been taken to the different countries where higher TSR levels has been utilized by various cement plants. So the visit has been organized to several Southeast Asian and European countries to see the best performances at the municipality level as well as the cement plant level. And various several submissions has also been given to the government for including co-processing as a preferred option. And as a result of it, multiple submissions, finally we got that policy necessary changes also in 2016. And also further amendments are also happening in the hazardous waste management rules as well as the solid waste management rules. And second activity is focused on the technical research. We also incorporated LCA thinking on the AFR usage. Many cement plants, we have carried out the LCA study for fossil fuel consumption, particularly to the AFR consumption. And what is the current levels of AFR in the country? One of the status paper has been released in 2016 and 2019 with the actual data from the Indian cement plants. And also we saw a 25% TSR to achieve. What are the waste available for the sector? So if you want to achieve 25% substitution at 2025 as a sector, as a country level, what are the waste available? And waste forecasting also has been developed and put up in various publications also. And several capacity building activities also carried out in the past in terms of conferences, missions to the best plants internationally and India level, and also the best policy happening across the world. So all these has been componented into this last 1 decade of activity. More than we started this in around 2008, and it's more than nearly completing 1.5 decades of work has been done on this. So currently, the manufacturing cost, especially the cost on fuel, is going up on very, very high. As we saw, it has gone as high as 3,000 rupees per MKCal. And the current substitution levels also at the Indian average is around roughly 5%. And the nation, the overall contribution by Indian cement sector to the nation in terms of emission is around 78%. And it also taken several initiatives voluntarily like LCTR, EP100, RE100, and they committed to reduce the emissions by 45% by 2050 compared to the 2010 levels. And we also saw the progress is also very well. We have done a status update with the support of WVCSD and other institutions, and it has been progressing well. We are ahead of our targets. And we definitely going forward and looking forward to achieve the target at 2050. So the increasing fuel cost and also the sustainability driven, now the AFR co-processing has been the need of the industry, and maybe we need to push it on a higher side with the very, very increasing fuel cost. So typical challenges, if you see in terms of what are the major, there are several challenges, but we like to list out some of the typical challenges. One is like identification of alternative material and a proper generator who can supply the material throughout the year, and how this material has been mapped and sourced. One of the key challenges of cement plant is to get the sourcing properly done, and what is the location, how much distance it is available. So all this has been one of the question marks. And also viable business model, because any TSR to work on a better way, we need a good business model to back up. And infrastructure and technology, several Indian players like AltSF also come into the market and presenting the technologies and infrastructure for the AFR. And looking forward for more level of technology for higher substitution levels, maybe at 20%, 25%, we need more technology supporters to support the industry. And in terms of bottlenecks in plant operation, especially emissions, the quality of clinker with higher levels of substitution, what are the impacts of it, and capex and financing constraints of the sector. So these are the typical challenges. And CA has been joined with the FLS for this particular study, which try to address few of the challenges, not all the challenges which has been addressed in the previous one, but few of the challenges we try to address by this AFR mapping study. This study is focused on at the group level or at the individual unit level also. We can vary this. We can vary the study based on the necessity of the particular unit. So this can be addressed some of the challenges and strategies to eliminate the bottlenecks. So we started this activity last year and facilitating and steams to be utilized in cement plant. So the three key steps of this activity is basically to identify and map the waste generators and waste streams that can be used in a cement plant within a specific radius of the particular cement plant. Assessing and shortlisting the potential waste streams as well as the generators, either it can be a generators itself or a waste suppliers or the processing companies, and also facilitating partnership with them in terms of creating a long-term association and also a viable business models with logistics arrangement. So these three are the key objectives of the study. So what the first activity we done is the baseline assessment and goal setting. So team has been formed with cross-functional members as well as led by the senior management team of the plant. And we understand their business needs and what are the requirements. And baseline assessment has been done on the technology, infrastructure, and also the performance of the plant in terms of TSR and fossil fuel consumption. And target has been fixed based on that particular activity. So here the particular plant in Andhra and Odisha, we have done a structure like this. The project leader will be the plant head. The team leader will be the departments, cross-functional teams involving all the people who are in the AFR. And also the plant like to set target based on this initial assessment is 20%, and the breakup for every 5% will be shared with them. How we achieve the first 5% TSR, second TSR, and third and fourth for 20%. So the study carries out in this way. So the baseline assessment of the plant is around 1 month, and identification, mapping, and shortlisting of AFR, which include fuels as well as raw materials with supplier details and quantity and quality in the next 2 months. And discussion and developing the viable business models in terms of creating all necessary requirements like logistics and other arrangements within the next 1 month. So typically it takes 3 to 4 months for this particular AFR mapping study. So as I said, it's a 2.1 million tons per plant, tons per annum plant, and the specific heat consumption is around 690. So the energy required is around roughly 732 tons of coal for a 330-day operation. For 5% of TSR and up to 30% of TSR, we calculated what is the requirement of alternative fuels at a CV of 2,500 kilocalorie average and 25% moisture and 330 days of operation. So we can see from 5% to 30% what is the quantity required at dry and multiplied by 25% of moisture. So what is the wet quantity required? So for plant, particular plant where the study has been done, required for a substitution of 5%, it needs 110 tons of wet quantity of waste at 2,500 kilocalorie. And for a 30% substitution, it roughly needs 659 tons of quantity of material for 330 days of operation. Similarly, the raw material requirement, there's a potential to substitute limestone with laterite of 5%. So particular has been based on the workings of the plant. So we arrived at what is the requirement of the raw material as well as the alternative fuel. So the next part is on the mapping study. So we use a mapping technology called QGIS, which is Quantum Geographic Information System Application, which is a specialized software for developing various locations or various mapping required based on our needs. It will give you the topography as well as a more precise location of the unit and details about the unit. So for this particular unit, we have done mapping at a multi-layered manner. The first circle you can see the cement plant is located at this is Odisha, and 50 kilometers, 150 kilometers, and 300 kilometers. What are the industries available? What are the municipalities available? Will be done. One of the main advantage of CII in carrying out the study is CII is having a vast network. There are a lot of industry members who are part of CII. So we also have a Greenco company rating system where more than 500 plus companies are working upon. And for them, waste management is one of the key concern areas, and cement plants can definitely address them. And CII also launched a waste exchange platform, online platform, where more than 100 plus members are available from the waste generators as well as the co-processing units, including the waste logistics provider, the waste processing company. So this network also utilized for this purpose. And several EPR requirements are come up in the market with the new EPR rules. So those FMCG companies also we are addressing with this mapping study. And the PROs, as a waste management companies like NEPRA and all, multiple people are working on this PRO thing, and we are also partnered with them in mapping this particular alternative materials as well as the generators. So this particular study has been done for a plant in Odisha. This picture, what you are seeing is a GIS mapping of a cement plant, where you can see the different dots, the red color, rose color, yellow color. It's calibrating the industry like pharmaceutical industry, dolachar industry, or an tire industry, MSW, urban local bodies from the cement plant location. So we try to map them based on this GIS mapping tool, which is an online tool with the copyright software we have. And also this is a mapping of generators and cement plants in Telangana region. You can see different kind of industries has been mapped here: railway workshop, pharmaceutical companies, FMCG, agri, cement plants, municipal solid waste generators, etc. will be mapped based on this. So once this mapping activity has been done, we come to know who are the waste generators in this particular state or particular radius of the cement plant. We try to assess them and shortlist them based on multiple parameters. One is the generation and availability of material on a long term, nature and characteristics, physical and chemical properties of the waste, the logistics arrangement where the cement plant needs to do the logistics, or based on the generation point they will supply at the plant gate, and viability for long-term options, like different scenarios, like we saw the COVID, there is a cut of material. So different range of scenarios we try to see and whether they can able to supply the material. And finally, the important is on the viable business models. We support both the stakeholders to create a win-win situation and facilitate them for viable business models also during this process. So based on this, for this particular plant, we shortlisted the following alternative fuels and alternative raw materials: red mud and fly ash, based on the various locations as a raw material. And in terms of AFR, we could be able to identify several categories of industrial waste like carbon black, spent pot liner, waste from tires, pharma, dolachar, etc. And also the other waste like agro waste and urban waste also has been identified for the AFR. So this is a list of output of the particular study, where we could able to identify 181 companies, out of which 160 are for the AF and other 20 companies for the alternative raw material. So this companies include variety of sectors like aluminium, pharmaceutical and FMCG, agro, several companies. So this is a typical result of that particular plant, where up to 50, 150 and 300 kilometers, they could be able to identify 180 companies who can be a long-term partners for them. And we also have an online platform, as I said, which have a pool of experts from pollution control boards and industrial experts also, who are working in the cement industry and are experts in the field of AFR management. We can use their support also for particularly seeing the characteristics of material and reducing the bottlenecks in operation of that particular industrial waste or hazardous material. So this platform also we are utilizing for that purpose. And regarding the policy and approval point of view or utilizing different waste, we are also using these experts in the process. And once this assessment and shortlisting has been done, we are trying to connect both the stakeholders, the waste generators as well as the users, through online virtual meetings as well as the physical meetings, to understand the specific opportunities and challenges for both the parties, and also facilitating long-term partnerships. For this particular company, out of 180 waste generators, we could be able to facilitate 25 meetings virtually as well as physically in some cases, and 11 major types of alternative materials has been identified both in terms of urban and industrial. So this 25 companies, we also facilitated visit to each other facility. The generator will visit the cement plant, as well as the cement plant will try to visit the generator location and see what are the MRF facility they have in getting the material. And this 25 companies includes variety of breakup, like government institutions, private organizations, urban local bodies, processing companies, EPR related requirements. So this is a typical case of one of the plant where we could be able to do this 25 kind of meetings. And the share of materials based on the study results, we could be able to identify 2 lakh tons of material alternative fuel supply per annum, and 4 million tons of alternative raw material in terms of fly ash or in terms of red mud. We could be able to identify and connect with the relevant stakeholders. In terms of share of this 2 lakh tons, you can see 18% is from the industrial and nearly 42% is from the agro waste. So since that particular location is very close to several agricultural area, so we could be able to get as high as 42% of material from the agro waste, and MSW, RDF and SCF RDF is refuse derived fuel, and SCF is segregated combustible fractions, we could be able to get 28%. Several urban local bodies we could be able to see in the process that are tied up with local players who are helping them in managing the waste, and we are directly contacting them and trying to get the better material for the cement plants. And also the plastic and paper are contributing to another 12%. So this is the breakup of this material supplied to the particular cement plant. So the summary of the study will be like this. You can see several materials has been identified in the industrial and domestic circuit, and materials identified through the study can able to achieve 25% TSR. As we saw, nearly 500 plus tons is required for achieving 25% TSR. We could be able to identify 600 plus tons based on an operation of 330 days of annual operation with 25% moisture. So which will roughly equivalent to 25% of TSR can be achieved in this. And the cost of the study will pay back you within less than a month, even for a 1% substitution. For example, a plant with 0% is able to achieve 1% substitution with this study. The payback will be very, very attractive. And with now the increased cost, it will be still lower. So this study has been now done in several states, like as I said, Odisha, Gujarat, and Tamil Nadu, and AP. So we are also partnering with several organizations in this process. And this is a roadmap for this particular AFR mapping study. It is put up in 3 phases. One is phase 1, where the waste mapping and baseline assessment will be carried out, and also the goal setting for increased TSR levels over a period of time. And phase 2, typically 5 to 6 months, where the technology upgradations, the FLS will play more part in this in assessing the current technology at the location infrastructure, and also supporting them in increasing this infrastructure to a higher level. And the third part is, after this co-processing levels has been achieved, we need to see what are the impacts in terms of energy, emissions, and quality of cement. So that will be assessed using an expert who have been available with CII for this purpose. So typically we can take up all the 3 phases together, which roughly goes to 10 months to 8 months, or we can take the individual phases based on the requirement of the cement unit or at the group level. Maybe only the waste mapping at 3 to 4 months, or only the technological evaluation at 5 to 6 months, and improving upon the infrastructure. Based on the necessity of the unit, we can be able to take up this particular study. So way forward, there is a significant potential to increase AFR co-processing currently from our average of roughly estimated around 5%. And this can also be a sustainable solution for waste management in the country. Cement plants can play a very, very huge role on this particular area. And it is also co-processing has been widely spoken and also internationally proven for managing various types of industrial as well as domestic waste. Both viable in terms of technicality as well as economically in several countries, and many developed countries like the European countries also utilizing waste as a source of fuel, and developing countries like Philippines, Malaysia, and other Southeast Asian countries also utilizing this as one of the source of material for co-processing. So CII and FLS will happy to work with the industry in accelerating the levels further. So thank you all. Thank you, sir. Thank you for the opportunity.
Thank you, Mr. Kandan, for an outstanding presentation. I think it's a roadmap for a company who's not doing any AFR, and how really go about it, and how, first of all, mapping the alternative fuels and raw materials available in the regions, and using a most advanced scientific tools, and also the experts' guidance. And then after that, then you also going in a systematic way how to create the infrastructure in the plant and how to upgrade the facility so that the plant can actually aspire to reach 25% of TSR. By chance, the particular plant, if location gives more material, there is a chance that the plant also can think of going towards 50, 60 TSR. Like if you see some European countries where there are some plants are working in a 100% TSR. There could be some plants of India maybe having a potential if such type of study is carried out. I feel that all the cement companies should use the expertise of CII GBC in terms of utilizing this particular facility. I think it is a quick way where we are able to get the OEM experience with the FLS, and also with the study of the comprehensive study by CII, and then also engaging with the stakeholders and industrial experts. All this is engaged, and this is a very systematic study. I think all the 1 decade of experience of CI has been brought into the study. I'm quite impressed with this the study results. I think it should be definitely many cement plant should actually look into this particular approach if they would like to do a very steep increase in their TSR. Now I open the session for the question answers, and people can share their questions on the system, and then we will be able to put to the people.
Sure. Sir, there are some questions on the Hive platform, sir, which I will read it out. Maybe you can assign to the individual speakers. First question is on size of RDF supplied to cement plants by Anthony Lara, sir.
Yeah, Mr. Anthony.
Sir.
Yeah.
The size of the RDF is around less than 80 mm presently.
The next question is also on the Anthony, sir, on logistics part. The logistics part has been carried out by Anthony team itself, or the cement plant has to take care of the logistics of supplying this material?
Presently, logistic part is handled by Anthony only.
Okay.
One more, sir, like typically 100 tons of urban waste is giving you yield of RDF how much?
Around 30%.
Means the 5,000 tons what you are getting in
Yes, sir.
Mumbai, and
Yeah.
that is capable of delivering some 1,500 tons of RDF.
So we are not. We are having bioreactor landfills over here. So 4,000 tons goes from
RDF quantity what you are saying, you're going to get a
Yeah.
30%. So means approximately if the off-takers are there, you are capable of delivering 1,500 tons RDF from.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
So another thing is that is a question from my side to you is that since you are processing all the waste for a quite long time, and how you address the issues, what are the challenges in terms of processing this waste material in terms of order? I think order is one of the major area of the concern for the people around these such facilities, and I see a lot of objections whenever we want to do a pre-processing facility in a particular area. We find that the community keeps saying about the order is one of the issue.
Yeah.
Second thing is about the safety. So basically, in terms of smell and safety, what are the issues? Fire hazards. What is that measures which you are taken in the facilities? What you are established across the country?
So basically, we are having a bioreactor landfills over here in Kanjurmarg. So what are the 4,000 tons we are directly adding to the bioreactor landfills, which is covered by our soil, and the rest 1,000 tons we are processing in the material recovery facility, out of which we are getting 30% of RDF and around 40% of compost.
Okay.
Yeah.
So you are treating in a three-way. One is the RDF, and then composting, and then is a secured landfill.
Yeah.
Okay. So is that in the long term you going to if you have off-takers, you're going to reduce the landfill composition, and then you'll try to offer to the companies? Currently
Yes, what the bioreactor landfill life is around 5 years. After 5 years, we have to excavate that bioreactor landfill. Within 5 years, we are using the gas and we are using in-house for the captive.
And means, are you going to generate power, or you are using for electricity?
We are already generating power from the gas engines, and we are utilizing
for your captive energy requirement.
Yeah.
Okay. And in terms of order, what are the steps which you have taken?
For order, we are using some odor depressant in our site. We are continuously 24 hours spraying this odor depressant.
Okay. Are you have a thermal oxidation of the VOCs?
No idea, sir.
Okay. So, thank you for the. You have any other questions?
Yes, sir. A few more questions are there, sir. Another 4 questions are there. So this is to Altesf. Typical capex requirement for infrastructure for roughly 10% TSR.
10% CSR, TSR for small kiln, and for bigger kiln is completely different. If we talk about, if we say about 5 tons per hour, basic manually feeding system, which can feed through some container and hoist kind of arrangement, it will range around 1.5 CR for complete capex. If it is quite bigger system where it is mechanized for feeding around 20-25 tons per hour with belt conveyors up to around 300 meters in length, the capex will range from 10 to 15 CR. It depends on length and structure and support and civil kind of some plus and minus will be there. But this is the range for the capex.
Just continuing that question, that if assume that the biggest kilns are in the range of 4 million ton kiln, and if you are looking for a 25% TSR, I see the Mr. Kannan's presentation about the quantity that almost he was talking about close to 700 to 800 tons, which required per day for a 30% TSR. So if you are looking about a 700 to 1000 tons RDF feeding into the kiln, in such case, that what is the type of pre-processing and co-processing cost? You see the total, both the things together, because plant should ultimately have the pre-processing and then need to have co-processing.
Some parts of India, the pre-processing is already managed by people like Anthony Lara. They are giving a bit processed material, although it sometimes requires some further processing. So cement industry started with single stage shredder. If we look at complete pre-processing, the investment for primary shredder, secondary shredder, screening, conveyors in between, then storage building, this will go for almost 35-40 CR in that range. Sorry.
Including co-processing, pre-processing plus co-processing.
Yeah, around that range. And when we go for, for co-processing, it is different. This requirement of around 1000 tons per day will call for at least 30 tons per hour, provided we run 24/7 the system. And for 330 days, whatever the time kiln is operational in the year. So for that, we need at least one automated grab crane arrangement, storage management, and then feeding system with conveyors. This will cost approximately in the range of around 25 CR in that range.
Means the combined it becomes around 60 crores?
Yes, around 60 crores, yes, sir.
With the indigenous machinery?
Yes. With indigenous, some of the machineries are imported in that, like
Some
shredder,
part of it.
Part of it, yeah.
So, yeah, Mr. Kannan.
Yes. Next question is on what are any capital subsidies available for alternative fuel processing equipments to enhance alternative fuel usage, like renewable energy? Any subsidies are available?
I think both of you can answer, Mr. Sunil and Mr. Satish, both.
For subsidies, precisely for startups, there are some subsidies I just came across for startup companies, but for cement industry to use this, how to get some more help on capex, I really am not aware about it.
Okay.
Sir, one more question, sir. What is the typical range of operational maintenance cost for equipments related to pre-processing and co-processing for variation in TSR?
In co-processing, if we talk about operational, more or less, it depends on what waste and what sort of impurities are there. Mostly whatever damage is coming is only due to impurities like stone or metal. If it is not there, we can say the operational cost is only kind of power for a year. If it is 2 years, certainly some wearing items like chains and belt has to be replaced. And if it is pre-processing, of course, there are so many issues with pre-processing. Any shredder you can buy, you need to replace 100% teeth within 2 weeks, considering today's scenario. So it's quite a high cost of maintenance in pre-processing. In specific figures depends on what is the capex. With relative to that, we can come to the OPEX costs. And project to project, we can calculate and help on that.
The next question is on the typical, what is the lowest pressure drop typically achieved by the back filters from Evonik, and also what is the compressed air pressure required for that?
Well, the pressure drop, which is normally 15 to 20% lower than the glass membrane. This is what we can suggest. In terms of number based on the plant, whatever available, uh, based on that, it will be less than 15 to 20% lower. So this will help into energy saving.
Say, for example, Ashish, if the particular filter is now you said about air to cloth ratio, you have a margin where you can actually handle additional flow. If you go
Right.
for additional flow benefit, then do you, still you will get any delta P benefit? I am taking the benefit of the flow.
Right. It's a very good question because you like to make use of both the things,
Yeah.
increasing the capacity at the same time the pressure drop. So ultimately, this will not that much 20%, then it will be reduced to 5 to 7 or 8% like that because you are at the same time compensating on capacity increase. This is how it
And
can go.
a lot of people have the apprehension that no, with the NOx levels if by chance are high. Is that any limitation for the P84 if the NOx and NOx levels are high? And also in some regions of India, we have a high SOx levels where the pyritic sulfur is there in the limestone. Whether the SOx and NOx, whether they have any impact on the P84 fiber life.
Okay, the P84 is basically polyimide, and its encyclopedia also says it's a thermal and chemical resistance. It has a good properties. So what exactly the SOx and NOx? How much amount of NOx will convert into NO2? That plays the crucial role. So we have to identify and guesstimate how much NO2 is coming because NO2 will cause
As
the
per the government, as per the government that we are permitted up to 1000 milligrams of NOx.
yeah, but in some cases, the conversion rate of NOx to NO2 is different. So
Okay.
if we are reaching to NO2 figures and based on the operating parameter temperature, because this together will play the crucial role in degradation of the polymer. So unless and until we have the data on temperature at the same time NO2, this will help us to guide about the degradation back life. Yeah.
Right now, your installations are working for the last 10 years.
Yeah.
And what is the experience of that? You know, having in reality the plants which have been operating on the different regions of India.
the, all the bags are running good. We can say that 99.99%. This we have not seen any failure or abnormal changes. Emissions are well below whatever committed, like 15 or 10. Because if you are expecting 5 mg per nm cube also, then you can achieve that. But you have to make use of fine fibers, and the field construction should be like that. So based on the current scenario, we will recommend 2.2 DTEX, which will provide better emission control below 10 and economical also viable because as mentioned by you, TCO will play a crucial role. Ultimately, how much bag life you are getting, emission control, ID fan power, DP lower. So all this factor will help and combine with this comparison to the alternative filter media.
And then you have any other
Yes,
questions?
sir. Another two are there. One is on this AFR mapping study that they are asking like CIA will also support in arranging the business model. We try to facilitate for arriving at a long-term partnership and viable business models there, but we will not take the financial decisions on behalf of the company. So that one point clarified on this, sir. And another one is for different industrial waste are coming into the cement plants. Plants are achieving 15-10% TSR with this industrial waste alone. What is the life of batch during that time with the Evonik experience on that?
I have shared a couple of slides because P84 can handle various types of alternative waste, whether it's a paste, pet coke or MSW or any different type of agri waste. Those are coming tire waste. So it don't have that much effect on the polymer. So it can handle different type of waste. Yeah.
Ashish, the important question is here is when we use higher amount of RDF, the chlorine levels generally are high in the system. And in such cases that many times we find that no, we need to install the alkali bypass, chloride bypass systems. before that chloride bypass systems are installed, have you faced any such problems? Normally, this problem occurs when you go to the RDF substitutions levels of 30 to 40%, and then you get a more chlorine coming from the PVC and many things which are used. But that will not be coming up to the baghouse, because in most of the time VRM, these particular chlorides and everything will condense. But that will increase our chloride levels in the clinker, but not coming to the baghouse. But did you experience that any alternative fuels where municipal solid waste is used large quantities? Did you experience any perceptible difference in the bag life, or any problems you have faced in your installations?
No, most of the application which we have seen, we have not identified anything like that in those region where alternative fuel has been used. As mentioned, chlorine and other, that has to be taken care, and how much it is coming, and bypass, alkali bypass, that have also installed. So after all those, this will help, because also emitting is not good.
So, Kannan, no more questions, no?
Yeah, sir. That's all, sir. You can conclude.
Yeah. So really is an exciting session, and we had a 360-degree view of the AFR utilization in cement kilns, and then the type of machinery to be used. And we have one the mega user, like from many municipalities, that we have a case study and what is the experience, and is also generator of RDF and compost, and also producing gas. And then we also have a machinery supplier who is talking about a pre-processing and co-processing. And also we have seen a filter which comes after the gas cleaning, and its impact on the particulate emissions and gaseous emissions. I think we have a 360-degree view, and also very, very important presentation of CI. They're in very key study, I think, which is going to be really helpful for every cement company who are having made a commitment to SBTi targets of CO2 emissions, and also made a commitment on net zero. And in the current context of fuel costs of coal and petcoke gone sky high, and it's now today what was not viable, every cement company like to see and carry out this study and see that how they can actually go towards accelerating this particular journey in terms of increasing the TSR. In the last 1 year, I could see a massive increase happening in the cement industry. And earlier people are only talking. Now today each company is investing money into the alternative fuels, both for the solid waste and also for the liquid waste. So I see a great journey. In the next 2 years, we can see a massive jump in AFR substitution rates in Indian cement industry. So thank for all the people who attended and then had many questions. I hope that questions have been adequately answered. If still you have some questions, you can at least write to our CI team, and they will get back to you with the answers. Thank you for joining the session, and have a great lunch, and join back on the next session.
Thank you, Chairman. Thank you, sir. Thank you all the speakers for sharing information and insights. The next session starts at 2 o'clock sharply post lunch, sir. Thank you, sir. Thank you all.
Thank you.